Today we will solve one of the example of NLPP which contains three variables and one equality constraint. Here also we have to use Lagrange's method. So to solve NLPP with three variables and one equality constraint using Lagrange's multiplier method. So let us understand the procedure. First, we need to define the function z, which is equal to f of x1, x2, x3, because these are the three decision variables. Then we have the equality constraint, which is given h of x1, x2, x3 is equal to 0. Then we are going to take Lagrange's multiplier as lambda, and we are going to write the equation L is equal to f minus lambda h. Then we have to differentiate L with respect to x1, means you need to find dou L upon dou x1 is equal to 0. We need to equate with 0. Here x2 also, dou L upon dou x2 is equal to 0. Dou L upon dou x3 is equal to 0. Also dou L upon dou lambda equal to 0. So in this way we will get four equations. Then we need to analyze the critical point. We have to check the maxima or minima of the function and finalize the solution. So here the point x0, which contains x1, x2 and x3, this point is known as the stationary point or critical point. Here we need to find delta 4. Why delta 4? Because there are three variables and we need to calculate delta n plus 1. Okay, so we need to calculate delta 4. So here first row, first column is 0, as we have seen in two variable method delta 3. Then the next we have to differentiate h with respect to x1, with respect to x2, with respect to x3, and write the same elements along column wise. Okay, because this is a symmetric matrix. Again here, as we have done in case of Hessian matrix, differentiate L with respect to x1 twice, then x1 x2 and x1 x3. Similarly you can complete. This is very simple procedure. We will see in the example. Now how to decide whether the function is maximum or minimum at x0. Okay, so here if delta 3, the value of delta 3, you can consider first three rows and first three columns. Here this will be the delta 3. So here if delta 3 is positive and delta 4 is negative, then we can say that function is maximum. Okay, z is maximum at the point x0. Z is maximum at x0. If delta 3 is less than 0 and delta 4 is also less than 0, means both are negative, then we can say that x0 is a minima. So you have to remember here the maxima or minima in case of this three variables and one equality constraint, it depends upon delta 3 basically. If delta 3 is positive, delta 4 is negative in both the cases. If delta 3 is positive, it is maxima. If delta 3 is negative, this is minima. Let us solve one particular example. So here they have given, z is given. So I'm going to consider z is equal to f. They have given h also. H is the constraint x1 plus x2 plus x3, this minus 10. I'm going to write L is equal to f minus lambda h. So this is equal to which is f is 12x1 plus 8x2 plus 6x3 plus minus x1 square minus x2 square minus x3 square minus 23 minus lambda times x1 plus x2 plus x3 minus 10. Now we know the procedure. What we have to do? We have to differentiate this L with respect to x1 partially, and we have to equate with 0. So if I do like this, so it gives 12 because the coefficient of x1, derivative of x1 is 1, minus 2x1 minus lambda equal to 0, dou L upon dou x2 equal to 0. It gives 8, then minus 2x2 minus lambda equal to 0, dou L upon dou x3 equal to 0, gives 6 minus 2x3 minus lambda equal to 0, dou L upon dou lambda equal to 0. It gives x1 plus x2 plus x3 minus 10 equal to 0. Now if you add these equations 1, 2 and 3, and we have to use equation 4. If I add 1 plus 2 plus 3, you need to solve these equations and you need to find x1, x2, x3 and lambda. So if you add all these equations, so 12 plus 8, 20 plus this 26, then you can take 2 common. So this will be x1 plus x2 plus x3 and minus 3 lambda equal to 0. From equation number 4, you can see here from equation number 4, x1 plus x2 plus x3 you can replace by 10. So this is 26 minus 2 into 10 minus 3 lambda equal to 0. So if you simplify this, this is 3 lambda is equal to 6. Therefore lambda equal to 2. Now you can use this lambda equal to 2 in equation number 1. You will get x1. Put lambda as 2 in equation number 2. You will get x2. And lambda as 2 in equation number 3. You will get x3. So if you substitute the value of lambda in 1, 2 and 3, we will get x1 is equal to, you can do here, the part is very simple. X1 is equal to 5, x2 is equal to 3 and x3 is equal to 2. Therefore your x0 is 5, 3, 2. This is your x0. Now we have to find delta 3 and delta 4. So we have to take the reference of the previous slide here. Okay, I'll write it once again. Here L, I'll write here L. L is 12x1 plus 8x2 plus 6x3 minus x1 square minus x2 square minus x3 square minus 23 and minus lambda times x1 plus x2 plus x3 minus 10. Okay, so now we know the delta 4, how to find delta 4. We require h also here. So h is x1 plus x2 plus x3 minus 10. So here this element is 0. Now differentiate h with respect to x1. So it gives 1, with respect to x2 1, with respect to x3 1. And you can write the same elements column wise. Then this element you have to differentiate. Already we have differentiated dou L upon dou x1. So we have the value of dou L upon dou x1, which is 12 minus 2x1 minus lambda you can differentiate this equation with respect to x1 once again. So if you differentiate this with respect to x1 once again, this will be minus 2. If you differentiate the same equation with respect to x2, there is no x2 and there is no x3 also. So second row is 1, then minus 2, 0 and 0. Similarly, we have dou L upon dou x2. You can differentiate it with respect to x1. You will get 0 with respect to x2, minus 2 with respect to x3, 0. Then the third equation also 0, 0 and minus 2. So this is delta 4. Now we will find the value of delta 4 and delta 3. So to calculate delta 4, first of all, determinant of delta 4, I'm going to use some column transformation. It is easy to find the determinant of this. So I'm going to subtract C4 from C2 and C3 from uh, yes, C2 from C4 and C3 from C4. Means I'm going to use C4 and I'm going to modify C2 and C3. So if I do this operation here, so it gives you this will be 0 0 0 1, then 0 and 0 1 1 and 1. Now this I'm going to change, which is 0. This will be minus 2. This will be 0 and this will be plus 2. Next will be 0. Here C3 minus C4, 1 minus 1, 0. Then 0. This will be minus 2 and this will be 0. This will be 2 here. Okay. Um, this is also 0. C4 is 1, 0, 0 and negative 2. Now, if I expand this along the first column, first row here, first three entries are, 0, 0, 0. So, plus 0, then minus, then plus, plus, minus, plus and minus. So, if you simplify here, minus 1 into 3 by 3, minor of this 1, I'm going to calculate. So if you find the minor of this, you will get first column is 1 1 1, then minus 2 0 and 2, and this will be 0 minus 2 and 2. So if you again simplify this, minus 1 into 1, then 0 plus 4, this will be plus 4, minus minus plus 2 into, you can simplify using calci also here, then this will be 2 plus 2, which is 4. So this will be minus into 4 plus 8, this is equal to negative 12. So negative 12 is the value of delta 4. Okay, delta 4 is negative, no problem. Now we have to check delta 3. Okay, because the maxima or minima depends upon delta 3. So here delta 3 is the delta 4, just you can take first three, first three columns and three rows of delta 4, you will get delta 3, which is 0 1 1 1 minus 2 and 0, then 1 0 and minus 2. If you find this value, first term will be 0 minus 1 into, I am going to solve the determinant here, the simple procedure, which is with the help of, I'm going to expand with the first row. So this is 0, second is minus 1 into this will be minus 2 and plus 1 into 0 plus 2. So if you see here, plus 2 and plus 2, this is equal to 4. So delta 3 is greater than 0 and delta 4 is less than 0. So we know that if delta 3 is positive, since here delta 3 is positive and delta 4 is negative, therefore your function z is maximum at x naught. So we have x naught as 5 comma 3 comma 2, and in this way you can find z max. You can substitute these values in the given function, which is 12 into x1, which is 5, plus 8 into x2, which is 3, plus 6 into x3, which is 2, minus x1 square 25, x2 square is 9, minus x3 square is 4, minus 23. So if you simplify, you will get an answer as 35. So z max is equal to 35 at 5 comma 3 comma 2. This is the stationary point. So in this way we have seen an example of NLPP. We have solved example of NLPP with 3 variables and 1 equality constraint. So here we need to find delta 3 and delta 4. If delta 3 is positive and delta 4 is negative, z is maximum. Similarly, if delta 3 is negative, if delta 3 is negative, in place of positive, suppose delta 3 is negative and delta 4 is negative, then z is minimum. Rest everything is same, all the procedure is same, all the steps are same. In place of z max you will get z minimum. So thank you.